Hello everyone. Today we are going to talk about what is Application Gateway for Containers. So Application Gateway for Containers is a layer 7 load balancing and dynamic traffic management product that is used for routing traffic in containers and Azure Kubernetes service. If you're familiar with, we have a similar product called Application Gateway Ingress Controller, which is using Azure Application Gateway and other resources within the cluster, in the case cluster, to route layer 7 traffics. But Azure Application Gateway Ingress Controller has few limitations, such as update when there's a new service or new ingress. It will take some time to upgrade the underlying resources and routes. Because of that, it is not efficient as um, application gateway for containers. So application gateway containers is a evaluation of application gateway ingress controller, right? And it is natively do application load balancing, and um, Microsoft recommend to use application gateway for containers for any new implementation and migrate from application gateway ingress controller. When you use application gateway for containers, it has few components, right? It built up with three components, right? So one is application gateway for container resource, then front ends and associations. And in this diagram, you can see a high level overview how the application gateway for containers will work, right? So you have the application gateway for containers that faces for public internet. Then you can use gateways and HTTP routes, Azure Kubernetes resources for creating routes and exposing application to the outside world, right? So keep in mind that if you are still using Kubernetes ingress resources for routing application traffics to external or internal, then application gateway for containers is not the product what you need, because application gateway containers is based on gateway API in Kubernetes. So it will use gateways and HTTP routes and other custom resources in the gateway API. So that's something you need to understand before you using application gateway for containers. So there are few features in application gateway for containers. Because it use gateway API, you can do traffic splitting, weighted round robin traffic. Then you can use mutual authentication to the backend targets, and as I mentioned, it supports gateway API, and it increase performance and real time upgrade when you for the adding or removing pods, routes and probes to the workloads. That is one of the limitation, and in the application gateway ingress controller we had, because it will take a few minutes to upgrade the routes, probes and adding removing pods. But application gateway containers will offer a better solution like real-time upgrade. Okay, so in the load balancing features, you can use automatic retries, then others like SSL termination, end-to-end SSL, then layer 7 traffics. So you can route based on a prefix like host path, headers, query string method likewise. Then mutual authentication also support. So there's a list of load balancing features that are supported by application gateway for containers. So and when you talk about application gateway controllers, for containers, there are two strategies. One is bring your own deployment, and another one is managed by ALB controller. So we will take a look at both of these options. First, I will show you how to implement managed by ALB controller, and next I will show you bring your own deployment option. So in the managed by ALB controller, there's a controller running inside the cluster, and it is responsible for life cycle of the application gateway for containers based on your request and custom resources. It will go and create a application gateway for container resource for you, and it uses application load balancer custom resource to create application gateway for containers, right? And it uses the gateway API as well. So if you want to route traffics to outside the cluster, and if you want to do like weighted round robin traffic, and if you want to route traffic based on headers, those kind of things, it still support with managed by ALB controller because it's using the gateway API. And something you need to remember is the supported regions. So at the moment, not all of the regions are supported, right? So you have to take consideration of the supported region as well. Yeah, so that's about the ALB Azure Application Gateway for containers. But before that, I need to show you some limitations that's also available also in application gateway for containers. So let's take a look at what are the limitations. Okay, there are some few main non-limitations, right? So in application gate for containers, one is it's only support layer 7, such as layer port 80 and port 443. Custom ports are not supported at the moment, so associate only for limited one. That means application gateway for containers currently support one association, that means one subnet. You cannot use it for multiple subnets at the moment. And private IPs are not supported at the moment, so frontend only expose public FQDNs. But if you want to route the traffic within the internally private IPs, then this is not supported at the moment. So subnet requires /24 larger. So if you want to use application gateway container, you should have a specific subnet which is more than /24 CIDR, right? Because it is using a dedicated subnet in the virtual net. We will take a look at it when we are doing the deployment and testing. And regional supports, as I mentioned, you have to check the regions because it's not supported on all the regions, right? So, and front ends cannot be shared as well. So the front end belongs exclusively to one AGFC, that means Azure Gateway for Application Gateway for containers, and it cannot be shared between multiple Azure Gateway for containers instances. Okay, now let's take a look at how we can deploy the application gateway for containers, right? So I have prepared the deployment script, right? So here you can provision both manage and bring your own option, right? So when you run this script, you can specify which mode strategy do you need, like manage or bring your own. Based on that, this script will provision the required resources for you, right? So when you talk about the resources for manage uh, ALB, Azure Load Balancer for containers, right? Application Load Balancer for containers. So you should have VNet, then you should have a AKS cluster, and it will use the AKS cluster uh, custom resource definition to provision the application gateway for containers, right? So if you go through this script, you can see I have a function here. So what will do is it will provision the required infrastructure, AKS cluster, and the VNet and everything. So you can find them in this main.bicep. So it is modularized. So you can see I will deploy organic workspace, VNet, then I have a deployed AKS cluster, and this is only used for if you're using bring your own option. So the application gateway container man through the bicep, but if you are using it through the manage, then AKS will do the provisioning for you, right? Because of that, in this first demo, this module is not needed, right? But yeah, if you're using bring your own, you need to deploy it by your own, right? Then it will update the enable the add-on, right? So I will use the case upgrade command, and with these two parameters, right? So enable gateway API, then it will enable the gateway API custom resources within the cluster, and it is using the enable application load balancer will install all the custom resource definitions and the required resources for the then I will get the credentials for the cluster. So get credential, then I will verify the ALP controller is installed. So if you enable this enable application load balancer, the cluster will have ALP controller pods, right? So these pods are responsible for managing the life cycle of the application load balancer for containers, right? Then you need to set up few permissions, because if you are using ALB manage Azure load balancer for containers, then it needs permissions like application gateway for containers configuration manager role. So we need to add a RBAC role to your AKS manage node pool, AKS manage resource group, because that resource group should have access to ALB controller to provision the required resources in that specific specific resource group. Because of that, we will get our manage resource group name, then we will get the load balance subnet ID that we created for specifically application gateway for load containers, right? Then you have to get the manage identity, right? So this is the default identity name, right? So it will get the manage identity for application gateway for containers. That manage identity is responsible for provisioning and authenticating the resources, right? Then we will add two roles. One is the application gateway for containers configuration manager role. Then we will add the network contributor role to the that specific subnets, right? So the network contributor role is dedicated to the subnet, right? then the application container configuration manager role is assigned to the manage resource group, AKS resource. Now we are going to deploy the ALB manage component for the cluster. So for that we need our subnet ID that is dedicated to the application gateway for container, right? Then we will create a specific namespace, right? Then we'll deploy the custom resource definition, all application load balancer, right? And we will associate to the subnet ID that we get from the above. Then it will go and provision application gateway for container within the Azure manage AKS manage resource group. So then we will wait until it is completed. Then we'll deploy the demo applications, and we will see how it's going to work. Right. So that's a high-level explanation of the script, right? But it has the option to use the bring your own option as well. So we're going to deploy it. So I will use deploy.sh and click manage, right? Then first it will look for any providers need to be registered. You can see it's already, the providers are already registered. So now it will deploy the bicep infrastructure, right? So we will wait until this is bicep is deployed completion, right? Okay, now you can see that the deployment of the AKS cluster is completed. Now it will go and enable the add-on, which is using enable application load balancer. Then it will take some time to upgrade the add-on with this feature. So let's come back after it's completed. Okay, now we can see the add-on is enabled. Now it's getting the clusters, cluster credentials. Then it will provision the ALB. It will check for the controllers are ready. So you can see there are 2 ALB controllers are running. Then you can see it will check the gateway class, because if you enable the application gateway for containers managed service, the gateway class will be created. So you can see this is the gateway class that use, right? And then after that you can see that it will going to create the permission, right? Assign the permissions for resource group and the subnets, right? Then it will deploy the custom resource for application load balancer for containers resource creation. So you can see application load balancer ALB network will be created. So then you can see it is creating the load balancer in this specific subnet, right? So after that it will go and deploy the sample applications, right? And gateway resource as well as HTTPRoute resource. Then when you create the gateway resource, right, and when we specify the application gateway in the gateway resource, when we specify if you get the gateway resource, you can see there are 2 annotations, right? So basically what we are saying is for gateway resource is which resources we need to use for routing the traffic, right? So here you can see we can specify the namespace and the ALB application load balancer container name. So by specifying these 2 annotations and the gateway class that we need to use, then gateway resource will leverage these application load balancer container for routing the traffic to the outside world. So when you deploy the gateway resource, then the application load balancer for container will create a front end component front end resource for you within the application load balancer for containers. So that's why we are waiting until we are getting a fully qualified domain name from the front end of the application load balancer for container, right? If you go to the Azure resources, right, then if you select the resource group, then you can see that the application gateway for container is deployed, right? So then you may see the front end is created, but still it is not created for us. We have to wait a little bit while. So we will take a look at the association, right? So you can see that this application load balancer for container is associated to that specific subnet, right? If you go to that specific subnet, right, then you can see a delegation of that subnet to that specific application resource type. So it's loading. Let's open it on a separate window. Okay, so I have opened it on a separate window. So let's go to that virtual network that we created, right? So if you go to the virtual network, right, then if you go to the subnets, then you can see there are the specific subnet for AL application load balancer container, and you can see the delegation, right? So here you can see this subnet is specifically delegated to the service networking / traffic controllers, right? So other resources shouldn't be deployed into this subnet. This is only specific for application load balancer for containers, right? Okay. So creating front end will take a few minutes. So we'll come back after the front end was completed. Okay, now you can see the front end is created, right? So here you can see the front end name in the application gateway containers, and you can see the domain name, right? So this is a fully qualified domain name for that specific front end, right? Then here you can see there's HTTPRoute in our gateway manage resource group. So in this HTTPRoute, here we have deployed very sample application like echo application, right? And within this HTTPRoute YAML, you can see we are specifying which gateway you are going to use, right? So for example, this is the gateway name, right? So gateway 01. So in the HTTPRoute, we are saying that we are going to use gateway 1 for this specific route. And there are few rules available in this HTTPRoute. First route is /path prefix route. So it has a /bar, right? Then if you type the fully qualified name and the /bar, then it will route the traffic to the backend v2 in the port of 880, right? So if I copy this URL, right? So then if I type the URL, So default it will go to the v1, right, v1 of the route, because this is the default backend, right? So you can see it is going to v1, right? But if you type /bar, right, at the end, specific path, then it will go to the v2, right? So you can see it's backend v2, right? Then if you specify specific headers and path routing, then you can use you can use path routing and headers and queries to send traffic to a specific backend, right? So here is an example for that. So here you can see there's a matches, there's a parameter called match. Then I will match the header for the type, for the exact match of name magic and the value foo. Then I will use a query parameter as exact name called grade and the value example. Then I am using a path for that query as well, called something, right, /sum and /thing, right? So if all of these three conditions are match, that means header, query param and path, then route the traffic to the backend v2, right? So we can try out that one, right? So for example, so what I'll do is I will replace this with fully qualified domain name, right? Okay, so what I'll do is I think we need to use curl, right? So I will use curl, that is much easy for me, right? So I will use curl, then I will use that specific header and the path and the query string, right? So if I write, then you can see it is directly sent into the backend v2, because in the route you can see if those conditions are matched, then you should route it to the backend v2, right? So so that's how the application load balancer for container works in the, if you are using manage option, which managed by the AKS clusters ALB controller, right? So if you type kubectl get pods, right, dash all, right? So let's take a look at, and then you can see there are two containers running in the kube system called ALB controllers. So for example, if you want to create an additional application load balancer for container, right, a different one, then what you can do is you can use the custom resource like similar to this one, right? Then you can provision it to the AKS cluster, right? So then it will provision a new application gateway for container resource within the manage resource group of the AKS, right? Then you can use that specific application gateway for container from your existing gateway API resource, or if you want to create another if you want to use it for a different gateway API, then you can use it. So if you want to have, for some reason, if you want to have two different application gateway for containers to route to different applications, then you can use you can provision two different application gateway for containers, and you can adjust your HTTP route gateway API resource to use specific application gateway for container resource. So that's all for the manage application gateway for container resource. Next, let's take a look at how we can deploy application gateway for container through the bring your own option. In previously, we have checked out how we can deploy the application gateway for containers with the use of manage solution. So in that scenario, AKS and the application gateway container controller will manage the provisioning of application gateway for container for you. But now let's take a look at how we can bring your own application gateway container to the Kubernetes environment. So the only difference is in bring your own scenario, we are going to create the application gateway for container through the bicep, or if you're using CLI or Terraform, you can use whatever the method that is convenient for you. So we are going to create it from ourselves, and we will integrate it with AKS cluster, and then finally we will use gateway and HTTP routes to use the application gateway for containers to route the traffic. So let's take a look at what we are going to do. So if you, as you can see in this demo files, you can see I have biceps module here. Then you will find a separate bicep module for application gate for containers, right? So this is going to provision the application gateway for container for you in the manage in the bring your own method. So, and we can see in the main main.bicep module, we have a if condition to check whether what is the deployment strategy. It is being your own deployment strategy, then only if we're going to deploy the application gateway for containers Azure resource. Otherwise we don't need it, because it will manage. If it is using manage, then it will manage through the AKS cluster and the application gateway for containers controller, right? So that's the major difference we have in manage and bring your own. In manage, we are not going to deploy it through the bicep. It will deploy through the application gateway for container controller by using a specific custom resource definition. But in your bring your own solution, then we are going to provision the application gateway for container. Then we are going to integrate it with the AKS cluster and the gateway API and the HTTP routes and so on, right? So let's go and deploy the required environment. So you can use the same deploy.sh command script, but here I'm going to specify a parameter called BYO, bring your own. So then it will go and deploy the bring your own application gateway container and the required resource. So let's run this. Then it will check the resource providers are already registered. Then as we did in the previous deployment as well, then it will take at least 5 to 10 minutes to provision a case cluster, then the VNets, then the application gateway for container, then required permissions and delegation of the VNet subnets and everything, right? So we will come back after this deployment is completed, then we will have a look at. Okay, now we can see that our infrastructure and the required sample backend applications are deployed. So as previously, you can see that we have ALB controller pods are running on the cluster because we have enabled the application load balancer in the cluster. Then we are, because we enable the enable application load balancer in the cluster, we will see a gateway class called Azure ALP external, right? So now we are going, what we are now doing is we are going to deploy the applications, right? So we will deploy the backend application, right? So it's a sample backend, same application we used previously, right? We have two deployment, version 1 and backend version 1 and backend version 2, right? Then we are deploying the gateway and HTTPRoute. So if you take a look at on the bring your own, you can see the gateway, right? Then you can see the ALB, the annotation ALB networking Azure ALB ID. So here we are going to when we deploy from the script, this value will be substituted from the script to the Azure resource ID. So let's take a look at in Azure how it is going to look like. So if you go to the Azure portal, then if you select the subscription, then if you go to the AGIC-demo, then here you can see that the application gateway for container is provisioned, right? And it is deployed into the AGIC-demo. Because this resource group is managed by us, so because of that I have deployed it into the this specific resource group. But if you can remember, in the managed solution, the application gateway for container will be provisioning in the AKS managed resource group, because this specific resource group, because this resource group is managed by AKS, and in previous manage option we have created a custom resource definition to provision the application gateway for containers. Because of that, as it is managed by the AKS cluster, then that resource is provisioned in this AKS managed resource group. So that's one of the difference, right? So now if you are using bring your own, so you bring your own solution, you can manage the application gateway container for your preference, right? So if you go to the application gateway for container, then you can find the front ends. This front end is provisioned through the gateway, right? So if you go to the gateway .yaml resource, right? So you can see that in the annotation we are saying it has to use this application gateway for container ID, right? Resource ID. So then this gateway will use the application gateway for container to create the front end, and here specifically we have mentioned which gateway class we are going to use, right? Then the listeners and the addresses as well. So we had put the type which what type of resource we are going to use. So we are using ALP frontend, right? Then we will replace the value of the frontend name. So this is the frontend name that is specified there. Then under the associations also you can see it is associated to ALB subnet, right? And it is dedicated to Azure Application Gateway for containers, as I showed in the previous demo. Now if you try to run these curl commands, right, you can see that the same demos that we've performed before, right? So if you curl the root of the FQDN, it will go to the backend.v1. Then we have HTTPRoute here, which will do the routing for these front-end URLs. As I explained before, we have different rules that are going to match. So for one of the rule is if you have a path called bar, then /bar, then it will go to the backend. Then you have a header plus query parameters plus path routing match. So if those three are matched, then it will go to the backend version 2. Then the default route should be backend version 1. So if you try to access the root, then it will go route to the default route. Then if you try to access the bar /bar route, then it will go to the backend v2. Then if you try to use the that specific path and the query parameters as well as the headers and everything is matched, then it will go to the backend 2 as well. So you can see it is routing to the backend 2. So yeah, that's the overall idea about application gateway for containers. So it's very pretty easy to provision, and if you are already in gateway APIs, if your applications are using gateway APIs, then application gateway for containers would be a good solution, because most of them are managed, so you don't need to manage internal ingress controllers, those kind of things. But you have to check what capabilities do you need for your applications, because some of the ingress features are still not available in the application gateway for containers. So it's good to check the features that are required for your applications are available in application gateway for containers. Okay, that's all for this demo of how we can provision application gateway for containers by using the manage option as well as the bring your own option, right? In upcoming videos I will try to show you how we can do the traffic splitting, then SSL offloading and backend MTLS as well, because application gateway for containers supporting these features. So we'll take a look at in a separate video. So thank you for listening. We will see you in another video like this. Thank you.